Okay, so we're going to look at two theorems now, Theorem 3 and Theorem 5, and then we're going to just do a question that'll bring in all of the aspects of it. So Theorem 3, to start off, has two parts. It says that if a transversal makes equal alternate angles. So if we remember, alternate angles are the ones that are on opposite sides of the interior. If they make equal alternate angles, then the lines are parallel. Okay. And then the second part of it just says that if there are two lines that are parallel, if two lines are parallel, then any transversal, so any line that goes through them, any transversal will make equal alternate angles. So it's just the opposite of the other one, alternate angles, the other way around. So all that means is, if I draw out two lines, now these lines, I can get them as close to being parallel, but I'm not 100% sure they will be, but they look pretty parallel. If we have two lines like this, and we don't know they're parallel, say, and we have a transversal going through them, if this angle here, so let's call it 1, if angle 1 is equal to angle 2, and angle 3 is equal to angle 4, then we know that these two lines are parallel. And the same goes that if we had two parallel lines, then we knew these were parallel, then these would have to equal each other if there was a transversal going through them. So that's Theorem 3. Now Theorem 5 is not too confusing. It just says that if two parallel lines are parallel if and only if for any transversal corresponding angles are equal. So it's the same kind of thing. So it just says that two lines are parallel. Two lines are parallel. And then we have this thing called if and only if. Okay? And it's a complete state. You can't have it any other way. These two lines are parallel there only can be parallel if this statement is exactly true, that for any transversal, so any line that goes through the two of them, for any transversal, corresponding angles are equal. Corresponding angles are equal. Just a reminder on what corresponding angles are, we'll go with two parallel lines again. So we've got one parallel line and another one, and we've got this through here. A corresponding angle is if we make a circle of kind of angles here, we're going to call this 5, 6, 7, 8. If we look at 1, 2, 3, 4, 1 is in the top left-hand corner of this kind of grid, isn't it? The corresponding angle to that is 5 because this is in the top left of this grid. 2 and 6, 4 and 8, 3 and 7. They're the corresponding angles. So let's just try out a question using these two theorems, and let's see if we can get the right answer out of this. So I'm just going to draw two random parallel lines and hope that they're parallel. They look parallel, but I'm not sure. And I'm going to draw a line, a transversal through them like this. Now let's measure our angle here. This angle looks to be, to me, 80 degrees, yeah. So this angle here is 80 degrees. And what I want to do is I want to find every single other angle in these, the interior, the corresponding, the alternate, all of these angles that are here. I want to find them by only knowing this. So I'm going to say we know these are parallel lines, okay? I'm not allowed to use my protractor either. We're going to get rid of that. So, first of all, we know if we go back to our earlier theorems, we know that along this line, we have to have, it's a straight angle, so we have to have it be 180 degrees. So this plus this has to equal 180. So therefore, this angle here is 100 degrees. Hopefully you're happy with that. Now, we know that these two lines are parallel. And because these two lines are parallel, then we know that the alternate angles are equal. So the alternate angles are the interior ones, so we can't do much with that yet, but we also know that corresponding angles are equal. The corresponding angle to this 80 degrees is this one here. So this must also be 80 degrees. And the corresponding angle to this one is this one here, so 100 degrees. Okay, so now we can go back to Theorem 3. It says that alternate angles must be equal. So this 80 degrees, the alternate angle for this 80 degrees is over here. This 80 degrees. And this one is over here, 100 degrees. And then we are missing, we have to go back to Theorem 3. We're missing these two, or Theorem 5, sorry. And Theorem 5 says the corresponding angles are equal. So corresponding angle 80 degrees goes here. And the 100 degrees goes here. So let's just do a little quick check. We started with 80 degrees up here, and we didn't know what any of the other ones were. Let's just check. We know that there's there's 360 degrees in a circle. So we've got a circle here. So let's add these together. 100 plus 100 plus 80 plus 80. If you stick that in your calculator, you will get 360. So we know that this is 360. These are all the same numbers, so this will be 360 as well. So we're happy with that. Along every straight line, do we get 180? We do. That's 180. This one, 180. Along here, 180, 180. They all get to 180. Our corresponding angles equal. 100, 100, 80, 80, 100, 100, 80, 80. They're all equal. Our alternate angles equal. 80, 80, 100, 100. Yeah. So because these two lines are parallel, we've worked out by only knowing one of these that all of these are true. So let's try one more of those questions. And we're going to work it out fully and do it the proper, with all the notation. So that was just a little talk through version. But if you're in an exam and you have to answer this question, here's how you would have to do it. So I'm going to draw a different transversal, more sharper one like this. And imagine that the question asks you that you have got, that's 60 degrees there. You have got 60 degrees and you've got all of these angles, A, B, C, D, E, F, and G. And it says find all of those angles without using your protractor. So we would say that using Theorem 5, which says that corresponding angles are equal. If two lines are parallel, sorry, we know these are parallel. And these little lines here, these arrows mean that they're parallel. We have two parallel lines. We know that they're parallel, so then the corresponding angles must be equal. So the corresponding angle to 60 degrees here is F down here. So by Theorem 5, F must equal 60 degrees. Okay, and I'm just going to put in this little bit of notation that you might remember from an earlier video. So we've got the measurement of the angle F is equal to 60 degrees. Okay, so now that we know that, we can work out that angle, the alternate angle. So by Theorem 3, we know that the alternate angle to F is angle B. Angle B should be equal to angle F, right? So 60 degrees as well. Now, so we've got those two filled in, essentially. And the next one, we're going to consider our other theorem. So we're going to go back to an earlier theorem. We're going to go by Theorem 1. So if you remember, Theorem 1 says that a straight angle will add up to 180 degrees whenever there's a line through it, essentially. So if we have 60 and we've got this missing bit here, we should add these together. It should equal 180 degrees. So we could say by Theorem 1, angle A, the measure of angle A, plus 60 degrees must equal 180 degrees. And with a little bit of quick algebra, all we have to do is throw the number over the other side, so that becomes a minus 60 degrees, and we end up with 120 degrees. So we've now got angle A, we've got angle B, and angle F. And I think that's all we really need. So if we think about it, the corresponding angle to A is C. So by Theorem 5, we've got A is corresponding to C, so angle A, or angle C, sorry, must equal 120 degrees. The alternate angle to C is G, so by Theorem 3, angle G must equal to 120 degrees. So now we've got G, we've got C, we've got A and B and F. We're left with D and E. But we know that the corresponding angle to B or to D is B. So corresponding angles is Theorem 5. So then by Theorem 5, angle D should equal the same as angle B, which is 60 degrees. And again, by Theorem 5, angle E, or E, sorry, not 8, apologies. Angle E must equal whatever angle G was, because it's corresponding, isn't it? And angle G was 120 degrees. And there you go. So, using only these theorems, you've gotten all of the angles figured out. So I'm going to rub out these things and fill in those numbers, and we're just going to check it all quickly before we finish up. It's always good to check your answers on these ones just to be 100% sure. So A, we said, was going to be 120 degrees. B, which was here, is going to be 60. G was going to be 120. C was going to be 120. F was 60. D was 60. And E was 120. Okay, first of all, I always like to check if it adds up to 360. So 120 plus 60 plus 120 plus 60. Work that out quickly. It should equal 360. And then let's look, what's the other thing we can check? Yes, all the straight angles. So 60 plus 120 is 180, yeah. 60 plus 120 is 180. 60 plus 120. If you go all the way around, it's always going to get to 180 on the straight angles. Our alternate angles are equal, 60 and 60, 120, 120. Our corresponding angles are equal, 60, 60, 120, 120, 60, 60, 120, 120. So just because we know these two lines are parallel, we had one angle picked out, we can figure out all of these angles on the inside.